CactusCon. Please help me welcome Dylan Hudson and his discussion about becoming a red team operator and what it's going to take to do so. Dylan, thank you.
Thank you, everyone. So I've been coming to CactusCon since 2017, so to have the opportunity to present to you all is very great. I'm grateful you all attended, and I'm really looking forward to demonstrating some of the things that I've learned during my time doing some red team operations. I'm currently 24 years old. I lived in Arizona all of my life. I learned about cybersecurity during high school, and I had the first opportunity to do some teaching with Gen Cyber, where I got to teach some high school students about cybersecurity. Some of my other experience comes from doing help desk from some time, working in security operations centers, and then moving to where I am now, which is at Cisco Systems, getting to work in internal red team operations. So I just want to mention that consulting operations where you're doing red teams are very different from internals. There's a lot of other information that you would have from an internal red team versus that of a consultant. Personally, I think the benefit of doing internal red teams is I get to see how organizations have improved over time and give them more information or see if they keep repeating the same mistakes. So the reason that I'm here is I was given the opportunity to work on a red team around August. So far, I've executed around 2 of them. These engagements are primarily related to FedRAMP, so working on trying to get organizations certified, working to ensure that they meet proper guidelines, and using what's been provided by regulators and trying to align tests to what they're looking for. There's also a little bit of confusion. There's a lot of sources out there about what the difference is between a pen test and a red team. Maybe my opinion's not right, but I'm going to do the best to describe it the way that I can. There's several tools out there that you can use to keep your team organized. There's some that have worked for us, so I'm hoping to show and demonstrate some of those, along with just kind of a general methodology. So I don't think there's any way that I could teach everything that there is to be about red teaming, but I am hoping that I can give you some pieces or ways to think about the tools that you use and actions you conduct and how they relate to red teaming. So let's talk about some of the baseline, like foundational knowledge, just so to understand that we're all on the same page. When you're doing penetration testing, you're trying to find everything you possibly can about the organization that you're looking for. And you don't really care about getting detected. Maybe they already know that you're coming. I mean, it doesn't matter how loud you are, where you come from. You're trying to do everything you possibly can to scan all their systems, look for vulnerabilities, essentially gather everything. You want to exploit everything you can. If you find a vulnerability, you'll go for it. There's not much consideration to OPSEC or operational security. We'll talk about what that is in a little bit. And primarily, you're just testing the technology. So you don't really worry about some of the other things. You're just looking at the systems that you're testing. When you're working in a red team, you care a lot about who sees you and when. You need to keep track of the actions that you're doing, when you're doing them, where you're doing them from, worrying about the traffic that your tools are generating. You're typically using something like a command and control framework. It's things like Cobalt Strike, which are enterprise versions. There's also things like Mythic and Sliver, which are open source versions of command and control systems. These are much different than something like Metasploit or even using something like Netcat and a reverse shell. The systems operate differently and intentionally work in ways to keep your activity hidden. Versus with penetration testing, where you're just looking at the technology. Red teaming is very important to looking at people, processes, and technology. The types of defects that you're going to be submitting to organizations vary a lot differently. Instead of saying like, hey, we found some misconfiguration on this server, this needs to be patched. It's okay, we found this IAM policy, which allows us to assume a different one. And when we did assume it, we did it from a redirector, or a redirector being some sort of external host that's public to the internet, not something in their environment. So let's say you use that credential on that internet-facing site, and then you're laterally moving in their network. There's several pieces there that you need to keep track of. Where did you execute those credentials from? What time did you do it? What was the role you were using? On top of that, you need to understand that it's not just this IAM policy is misconfigured. You're now telling them like, hey, we used this policy and you didn't detect it. You didn't respond, you didn't remediate, you didn't do any action to prevent us from doing it. Some of the things that you may see here are like mean time to detection, or MTTD, and mean time to remediation, or MTTR. So if, for example, let's say that the defensive team just removes you from a system, or you're able to compromise it and all they do is delete it. Well, sure, they've solved the problem of removing you, but now they have no forensic evidence. They have no idea what you did on that system, how long you were there. And so the whole point of red teaming is to assist and give guidance to your customer, being the blue team, and providing them with ways to grow and showing them in areas that they can improve. So this is the job of the blue team, and they have a very difficult task to complete. Being in a red team, we only need to be successful once, and we really only need to be able to move to our objective and get there in a timely manner and in a way that doesn't get detected. Something I forgot to mention is that when you are in a red team, you're taking an objective approach to your testing versus just finding the things. So you want to say, okay, our objective for this operation is to prove that we can exfiltrate customer data. And no matter how you reach that objective, you can consider it a win. So you don't care about finding every vulnerability, you care about reaching your objective. Some of the other areas you may look at is you're typically working with the customer a lot more as well. So again, this is just perspective that we've done. We usually look at things from an external perspective, from an internal threat, from a customer internal threat perspective, and also from a compromised SaaS. So like software as a service, putting ourselves in an assumed breach scenario on their systems so that we can immediately test their logging. It is kind of cheating, like you are bypassing maybe a lot of security controls that they had externally, but when you're giving time boxes, when you're given maybe 4 or 6 weeks to complete an engagement, you don't have time to do that. It's a lot easier to just have a compromised SaaS scenario, and you get more value out of it as a red team, and so does the blue team, because you're doing real attacks on our systems. So talking about what the blue team has to do, they have to detect everything. They need to know what the red team's doing, so they need to be right 100% of the time. If you can reach your objective, that's great, but they have a very difficult task, and they often are working different shifts than an offensive security team is. I've only worked in a couple places, but I've only ever worked typically a 9 to 5 in an offensive security position, versus the people who are working in security operations centers have like morning shifts, they have swing shifts, they have night shifts, and you want to work with these people and be kind to them because they're your customer. You don't want to beat them up. There are things that may be in place that you don't know about. Maybe budgets restricted people from getting tooling that they needed. So just keep that in mind. You want to provide the blue team with as much as possible. Timestamps and artifacts. Artifacts being hashes for files that you dropped, IPs where you came from, and also just being generally kind to them. So for example, we usually try to not do anything on Fridays or holidays. I think there's nothing worse than receiving a page on the weekend that someone's compromised your system. And I would be even more upset if I learned that compromise was something that was known by leadership, and I'm now having to get up at 2 a.m. for it. So I would definitely, again, these are your customers, be nice to them and treat them fairly. Okay, in terms of the red team, this is the Lockheed Martin cyber kill chain. Some of you may be familiar with this. These are the actions that you're taking. And sometimes it's not always just a straight pathway from recon to action on objectives. Sometimes they'll do reconnaissance, break into a system, and then you'll laterally move, and then you're going back to reconnaissance again because you need to do internal reconnaissance. You need to understand what it's like now in their environment. So this is what you're going to be doing, typically most of the time. Sometimes when you're looking at it from different perspectives, you may be a little later in the kill chain or a little earlier, but every single time you're going to be doing some sort of action that aligns with this. Okay, the other part is your control group. So you may have heard from physical red teams that people get arrested at times. Typically it's because of a break of communication between the red team and your control group, the people that are in charge of you and are likely directors or vice presidents who are aware that this is going on. Ideally, you want to have people in that escalation chain who can stop and know that something is going on. For example, if you do compromise a system and one of the analysts identifies it, you want to make sure that by the time it gets to someone who's escalated, that that's a person that is aware that the test is going on and can deconflict. Otherwise, you're going to have problems where they may get security involved, they may get legal involved, and you do not want that. It's great if the blue team detects you. That's exactly what you want. We also want to make sure that you're able to continue testing, and that you're able to not step on any toes while doing so, and that the control group is very aware of what you're doing. For example, if you're going to be sending a phish to multiple of their, to several employees, you may want to tell your control group, hey, we intend to phish your employees. You don't have to provide them with everything, but at least give them the time that you're going to be doing it, the narrative that you're going to be giving, and letting them know this is a thing that's going to happen. You also don't want to phish the people you're working with. So if you have people in your control group, do not phish them. At least it's recommended not to, because you're just making adversaries out of them. You're going to say that you're going to do a red team and then test the people who are signing you off. That's not a great way to approach things. Okay, everything that you're going to be doing in a red team operation is likely to align with the MITRE ATT&CK matrix. So I'm going to give a quick overview of what exactly this is, how to navigate it, and how to feel a little more comfortable with using it. So this is what it will look like when you visit it. Let's see here. Okay. Everything is going to be described as a TTP, or a tactic, technique, or procedure. When you navigate to this attack matrix, everything you see here on this top bar are your tactics. Your techniques are what are within this column. For example, active scanning. Every single technique, excuse me, is going to have an identifier. For example, I believe that's T1595, and that will come into play later. But every single thing that we do here is going to have some sort of identifier by MITRE. Now, it's not perfect. Sometimes it's a little difficult to identify what you're doing and see how it aligns with this framework. However, I found that if you use something like large language models to kind of give it some insight into what you're doing, it can actually give some pretty good suggestions as to the type of TTP it will align with. Now, when you go into these, this is the last part, which is the procedures. So they'll give you actual examples of things done by real threat actors and the procedures that they take and that they used, along with some of the tools that they used. Maybe there's some things that they utilize which that you're not familiar with. This can give you some guidance sometimes as a red team as to the next action you should take and the tools that you should use to do it. Okay. In terms of other things to be aware of, this is called the pyramid of pain. The blue team is going to utilize this to see how much they can drive you crazy. They're going to want to make your life as hard as possible. So this pain that you're going to be feeling is as the red team. Everything at the top, if you're caught in those top pyramid boxes, it's going to be very agitating to figure out how to get around it. For example, if you're using a certain tool, I'll just say if you're using LinPs all the time, and then they now signature LinPs, you can no longer use that tool. That's been burned, per se. While something else, where if you have something like hash values or IP addresses, those are very easy to change. You can change an IP if you're on AWS with a new Elastic IP, or you can modify a file by removing or changing a character, and you have a new hash value. So that's what this intention is. The blue team is going to use this against you, and you need to use it yourself to understand how much work it's going to be to get this stuff fixed in the event that you are burned. So being very careful about the tools you're using, where you're using them, and also spending time in places that are worthwhile. So I mentioned it a little earlier, this term OPSEC. It is very important that while the people you are testing are secure, you need to make sure that you yourself are secure. The last thing that you need is for your own red team infrastructure to be compromised or identified by something like Shodan or Census or even a SOC operation analyst starting to investigate some of the tools that you're using. It's also important that you communicate to others when you're doing things. So I'm sure a lot of you work on teams where you have people who are in other regions. Maybe you have people who are on the West Coast, the East Coast. You have people who are in completely other countries. It's very agitating to align timestamps, especially when you have things like daylight savings. Luckily in Arizona, we don't have to care about that for the most part. But for teams that do use different daylight savings or are in different countries, having something as a universal code and a universal format of making a time makes things a lot simpler. So ISO 8601 is just a complicated way to say this is how you should write dates. So this is also beneficial if you use something like Excel to track your engagements. If you put it in this format, you can sort by time, and you'll now have a list and an exact time frame of when you were doing testing and have them in order from when you started to where you ended. Let's give some examples of operational security. This is an example of GoPhish. Are any of you familiar with GoPhish? Okay, so this is a pretty simple tool, allows you with a pretty simple interface to do things. For some of you who may have used this, there's an administration port on 3333. There's no reason this should be exposed to the internet. This should be something that's private to you and your operators or your engineers who are working with you. Another example is this port. If you've ever used Mythic before, which is a command and control framework, you can see that there's several servers that are publicly facing for an administration portal. Again, set up firewall rules, configure your infrastructure in a secure way so that you can complete your operation, but also ensure that you yourself are not identified. So as you mentioned with GoPhish, and there's other tools out there that are a lot more effective. This tool doesn't do thing like 2FA capture like out of the box or anything like that. But it is pretty simple, and it's one of the tools that I had used when I had first started, and there were things I didn't know about it. So for example, if you were to send an email to someone, it'll automatically append a header to your email saying that it's GoPhish. This isn't the only tool that will do this. Again, evil Nginx will append things to your proxy traffic that's sent over. It'll tell you that it's from evil Nginx. You have to go into the source code and evaluate it and see where these identifiers are to make it less simple for the blue team to find you. So when you're looking at these tools, oftentimes there are people who have already done this extensive research. So if you just look for things like tool name and then Easter egg, or tool name and just modification that people have made on GitHub, maybe you can see notes as to why they made certain changes and why they've configured things the way that they have to make themselves more secure. So this is just if you send the email to someone. Another example is if they actually click on it. The same thing here. The server that is hosted by GoPhish is exposing that it is GoPhish. So this stuff can be modified by changing whatever you need to in the code. And there's a lot of good articles out there, for example, by Sprocket Security, which go over exactly how to do this for GoPhish. So how would we configure this in a secure manner? In a realistic manner? What we'd want to have is a way that we could access the administration portal over something like SSH. So that way we don't even have to open the port to firewall rules or anything like that. We can just say allow SSH from our operator and engineer IPs, and then just use a tunnel to access 3333. And now you only have a couple ports open, for example, HTTP and HTTPS, and 22. 22, your engineers are accessing, and your landing page on 80 and 443 is being accessed on by people who you are phishing. Another thing that you can do is deploy something like Nginx in front of your GoPhish server and configure rules that only allow people who need to be accessing the server to get there. This also prevents things like the headers from being exposed, as it will just say Nginx on it. So you can say like don't allow, let's say you're phishing, let's say that your red team operation is against a customer that's in the United States. You can remove all other IPs unless they come from the US. You're already preventing a lot of other scanners, a lot of other bots from potentially hitting your system. And you're ensuring that only the people who need to access the system who are being phished are reaching it. It also makes things more realistic. So attackers will often do the same thing. You have a GoPhish server that only you can access, and then you're setting up a redirector or this Nginx server to route the traffic properly based on the request being made. For example, you could put in your configuration to only allow the word bearer through the URI or through that parameter that's being sent. And this will prevent other people from investigating your server unless they have the proper configuration or are using the proper parameters. Let's give another example of why operational security matters. This is an example of network traffic from a Meterpreter reverse HTTPS shell, which I'm sure some of you used before. We're running our listener on the left-hand side. We're going to execute it on the right, and we're listening for all traffic going to 443. Okay, we can see that in a small span of time, we have about 500 packets being sent between our listener server and the system that we're compromising. The way this is also working, this is constant. So this network traffic is going to keep going and going and going while this shell is active. This makes it very challenging for you as a red team because you're having to have this shell open all the time, which is going to be very obvious. And using Meterpreter itself, while it gives you a lot of features, it gives you a lot of modules that you can use against the system. It is also very obvious and loud, per se, from a network perspective. So given that small amount of time that we executed this, we have about 2,500 packets being sent over the HTTPS port from this. Let's take a look at another example. Let's see. Okay, this is a Meterpreter reverse TCP. Doing the same thing here. Looking at our network traffic, we're just going to execute it on the right-hand side and go ahead and get it started in a moment. Similar situation. Okay, we have several packets being sent very quickly, and it's going to be a constant connection anytime we're interacting with this system. Anytime you're using something like Metasploit or Netcat, you have an open session with the system that you've compromised. This will keep generating traffic until you shut it off. This is where the benefit of command and control systems arrives. In this case, we're going to use Mythic. Mythic is an open source command and control framework that's built out very well. Let's go over some of the terminology you'll hear when using command and control servers. You'll typically hear something like a beacon or agent. This is what you're actually deploying on the system. You're going to hear things like listeners. This is what's actually listening for the connection. In this case, the payload we're using is something called a Medusa agent, which works on Linux systems. And the listener that we're using is HTTP. So let's go ahead and execute this demo. This is going to be a little different. So we're not just executing it directly off the system. We're actually going to curl the command and control server and pipe it directly into Python. Now you can see we have several packets, and there's actually much more than some of the other demonstrations. But what I want you to keep in mind is this is on top of a download, and we have it running in memory. At this point, we have it in another forked process, or sorry, in a background process, and it's going to continue running. You can also see there's not nearly as much movement on the left-hand side as we saw on some of the other systems. So I've paused it for a moment. The terminal that we had showed the execution. This is the GUI interface for Mythic, a lot simpler to navigate. On this system, as a lead, you can tell or configure what you like your operators to run. So on these agents are very risky commands. You don't want operators removing the entire file system. It's not ideal, especially because a lot of your testing is probably going to be in production. What Mythic allows you to do is restrict the users who are working with you to only run certain commands. So let's say that you really want to allow someone to shadow on your operation, but you don't want them running risky commands. You can control that with Mythic. Another thing that this does is it organizes things for you in a much simpler way. So we can see on the top on Mythic, it says interact. This is the callback that you're going to be operating with. Gives you some general information about what the shell is doing and some of the like the PID, the user you're running as. But what I want you to pay attention at is last check-in. Now, I did skip a lot of the time that it took during this demo, so you're going to see the time jump around a bit, but there's a real difference that you're going to see in how command and control works versus using something like Meterpreter. So right now, we're loading the command shell. When I first put this module on the system, I only had 3 things on it: the functions of sleep, exit, and load. This makes the payload very small. It only has the functions that it needs to do what I want it to. I want it to exit in case something goes wrong. I want it to sleep because that time is important, so it's not executing every second. And I want it to load so that I can bring in other modules that I know will assist me. In this case, shell. Different from Meterpreter, I've sent the command of shell, but nothing's happening on the left. Now it is. This is because it's checked in. So we now have our command loaded of shell, and we generated some traffic on the left. Now we want to list what's on the file system. Once again, we see that it has a status of submitted. We wait a moment for it to check back in. I'll just take a moment. Okay, we can now see that it has agent processed. So we submitted the command on the user interface. The agent checked back into the server and said, okay, I see I have a command for me. Let me pull it down. So now the agent is processing the command. When it did that check-in, we saw the traffic appear on the left. We wait again for some time before it checks in again, and we have our results. So while this is here, let's take a look at some of the sizes of those Meterpreter payloads we were executing. The reverse HTTPS is a very large file. And if you're going to be placing that on disk, and there is ways that you can run Meterpreter in memory, right? In this case, since we have it on disk, that is a lot of file of payload that you're going to be placing on a customer's system. And it's likely to cause some concern for people who are watching logs. Meanwhile, if you run it in memory, there's nothing on the disk at all. It's running on the RAM. If it restarts, then it's going to have issues, but this is where you implement things like persistence. But it allows you to have a lot more control of the machine and be a lot quieter. So that is one of the benefits of using something like a command and control framework is, again, that operational security, because you don't want to be found. Well, you don't want to be found quickly. So while you have more stealth, it does mean that there's more time. In this case, we just did a check-in of a minute or so. In some cases, we usually have these sleeping for about an hour. So just for demonstration, I'm showing that I'm changing the sleep to 3 seconds with 10% jitter, and I'll talk about what jitter is in a moment. But it's just to show that as you adjust the sleep, we're seeing a lot more network traffic on the left-hand side with Wireshark. Again, just another example. Now we have it checking in every 1 second, which I wouldn't recommend. So one of the values that you see when doing this is it says, for example, sleep 500 seconds with 10% jitter. So what is jitter? If you were to set a sleep of 60 seconds and a value of 20% jitter, your agent will call back between 48 and 72 seconds. Why would you want this? As an analyst, when you're looking at logs or you're threat hunting, it would be very suspicious if all of a sudden you see your systems have a baseline of this and then are suddenly going off the charts because of an amount of traffic that's being generated. Similarly, if you had it sleeping every 60 seconds and didn't add a jitter, you would see blocks, okay? You would see every 60 seconds there's some sort of event occurring. Versus if you add jitter, you have, okay, every 60 seconds something's happening, and then now every 48 seconds something's happening. As you expand the amount of time that you're sleeping and modify your jitter percentage, you're making the chart look consistent with normal network traffic, and you're hiding in what appears to be something completely normal. So let's talk about how this system was configured using Mythic. This is an example of how this is done. Similar to GoPhish, only the operators can access the administration portal. Everything is routed through Nginx. So we're able to have everything hosted on port 443 and 80 without having to open any additional ports. Basically, everything is routed to specific containers in Mythic based on the URI. So for example, let's say that in /login is your GET requests, and /post is something like /form. Okay, so if the implanted device uses /login, it's going to be sending GETs. If it uses /form, it's going to be sending post. And Nginx will route them exactly where they need to go and allow you to use the same port and ensure everything is encrypted. You don't even need to configure encryption between Nginx and the Docker container on Mythic because Nginx encapsulates all of it for you. Similarly, when the request is actually made to download the file for the payload, it goes to a completely different path, for example, SSO. So now when the system is accessing SSO, it pulls the file, versus when it's accessing login and form, it's now interacting with our Mythic command and control server. And then lastly, if we have a connection from something like, someone connects to Nginx from the SOC, it'll route them to a completely benign web page that looks completely normal and is of no harm to them. This is exactly what we want. We can configure, for example, in our listeners to use a specific user agent. Maybe we just change one digit in the user agent, so now we know in Nginx to filter for an invalid user agent that wouldn't work if you were to put it on a system, but one that we're expecting because we've instructed our listener to go for it. So this allows us to restrict traffic to only those we're expecting it from. How do we get a trustworthy domain? You can use something like expired domains, which has several for you that you can pick up for pretty cheap. If you use something like Route 53, you can grab some domains that look exactly like a trustworthy one. If you use something like healthcare or finance or some sort of other expected domain wording, it's going to look a lot less suspicious than just going to something like a .xyz or just a straight up IP address. This allows you to obtain a domain that's not expensive, that's legitimate because someone else used to have it, and it gives you multiple options in terms of having things that are already have a good reputation for the most part. Another example of things to be aware of in tooling is things like TruffleHog. Does anyone think that using TruffleHog would potentially get you burned on an engagement? Okay. There's a system on here with TruffleHog that does help you organize your findings, but is also risky. And that's because there's a flag in TruffleHog called no verification. If you do not use that, TruffleHog will verify that the credentials you're using will work. So we have an example here where we have some developers repository. They added some credentials on there to assist them with their tooling. We take a timestamp of when we ran TruffleHog. It's going to go ahead and do its thing. And we can see that we have a few results. So to TruffleHog's benefit, there are things called canary tokens. If TruffleHog finds a canary token, it will skip it. And this is because some of the research that the TruffleHog team has done. The reason this works is they can reverse the AKIA or the key of AWS, and canary tokens only uses a few accounts. Because of that, TruffleHog can identify them. However, if your customer sets up an environment where they don't use canary tokens, but use something like GG Canary, which is an open source solution, TruffleHog has no idea what that account is, and you will flag a canary token. So we'll skip some of this for time. Oh, okay. We can see in some of this that we have several results which identify the canary, and then another result where it didn't. In this case, we see that we use GG Canary. We ran this test at the 22nd of January at 8:19. You'll see in a little bit that we receive a Slack message at 8:23. That is not a lot of time for you to use the credentials, and now the SOC is fully aware that you're doing something within their environment. The whole point of these is to let them know that something is happening because there's no reason someone should be using these credentials. Another example is the tool called PACU. This is a very good tool for analyzing AWS environments. Similarly, it has a feature, there's a check called IAM Privest check. If you run this without a specific flag being scanned only, PACU will automatically exploit the AWS account that you're using, which may not be what you want it to do. It's conducting actions that you had no idea it may had you not used this flag, and you're now making modifications to a potential production account that you weren't supposed to, and you could make the SOC again aware that you're doing something. Okay, this is now, I'm sure, everyone's favorite part, which is how do we tell the customer what we did over the last few weeks of this engagement? An example is something like using the NIST Phish scale. This allows you, with several different factors, to determine how well the people that you tested did. If you were to send them a difficult phish and you have several people, like a 90% click rate, it's expected. And it's a lot more fair to the customer to provide them why something like that happened versus just saying, you got phished, we got you. It allows you to say, okay, we used a little bit of an easier phish and your employees clicked on it, meaning that maybe there needs to be some more training. Versus we made a difficult phish and multiple employees clicked on it, it's a little more expected. So everything is graded on the Phish scale by a Q type and a grading. And this allows you to determine how your phish aligns with its scale. Based on what's in your phish, you can then align it to this matrix and provide to the customer still an objective approach, but something a little better than just saying we phished you. We phished you, this is how difficult it was, this was the result. Okay, I've discussed a few things. Gone over tooling. I know that I kind of jumped around a bit, but the whole point is you're going to use tools throughout your environment, and you need to know what they're doing. You need to know what sort of traffic they're generating and how the SOC can identify you. It's perfectly okay to use the open source tools that you're used to using, but just be aware that there's things that they do sometimes that you need to be a little more careful about when conducting an operation in a covert manner versus just going about and testing your environment. So when you're working with several people, it can be challenging to know who is doing what, and you want to make sure you don't duplicate efforts. This is where Vector can assist you. So give me one moment as I authenticate here, and then I'll show it on screen. But Vector is not the only tool that allows you to do this. There's things like Ghostwriter, which allow you to track this sort of information and make it a lot easier. But I personally enjoy Vector a lot because I feel like it's helped out on engagements. Just give me one moment here. Okay, this is what Vector looks like. Everything in Vector is organized as a top-level thing, and then it breaks down into more specific items. Everything starts as an environment. In this case, we're in Team TNT. We then have assessments. In those assessments, we have these campaigns. And in these we have assessments. In these campaigns, we have perspectives that we can take. Example is external attacker. Now we have everything that we've done for an engagement aligned to MITRE and put in a chart that makes it easy to see what exactly occurred and when. Everything is organized as a test case. So the whole intention with this tool is to be a purple team tool, but you can use it as just a red team tool. You place what you did as an operator on the left, and then if you choose to share this information later with the blue team, they can enter what they did on the right. It also lets you track when you did and when you started and stopped your attacks. So now you have timestamps of when everything was executed. You also get, once you finish testing, a heat map of how what you did aligns with their security posture. If you have coordination with the blue team, it can be either during or after the engagement. They can align, they can add what they found or what they didn't find to your test cases, and then it will go on this. Anything that's green would be aligned as a strong defense, meaning that they identified it or they completely blocked it, while things that are orange or yellow or red would be things where there needs to be areas of improvement. While I don't have it on here, if you do more of these engagements against your customer, it'll show you over time how well they've done and split up exactly what was done during the engagement. This is important to a red team because you may not always have findings, but you want to tell your customer that you have actually been doing things for the last 4 weeks. Just maybe some of them weren't successful, which is a benefit to them. But it makes sure that your work is documented even if attempts failed, and make sure that where things were found, you have them documented in a place where everyone can see them and collaborate. Okay, gone over multiple things. Talked about tooling, talked about operational security, talked about the things to consider when you're conducting these sorts of engagements. I think the last thing that I'll leave with is something that you want to consider when you're doing an internal engagement especially, is there's a lot of bias. There's a lot of information that I have as an internal employee that an attacker would not if they were to land in the same environment. However, when you're in a time box, sometimes you may need to cheat. You may need to look at other resources that only you would have access to as an employee and use them to your advantage. So if you're going to cheat, cheat fairly. I'll give you an example. Let's say that you have one operator who's been given internal access as the customer's engineer. You have another operator who's on the compromised SaaS. The operator who's on the compromised SaaS discovers that they're able to query the IMDS metadata service in AWS, and they take credentials. As an attacker, if you were to obtain these credentials, you would not know the policy that's aligned to them, so you wouldn't know what you could or could not do. However, given that we have several perspectives, meaning that we have an internal engineer who has customer access and the compromised SaaS scenario, we can use the access that we have as an internal engineer to look at the policy and see what we can do. This gives us guidance as to the actions we can take in a small amount of time and gives us a complete pathway as to what we can do. So this is just an example. Some other things are if you have internal tools like security dashboards that show you maybe some vulnerabilities that may be on external systems, that's perfectly fine to use those. However, I recommend generating the same amount of traffic that an attacker would if they were to find the same thing. So in that case of the IAM credentials, we now know as operators exactly what we can exploit, but we should still run tools like enumeration tools, like brute forcing tools to generate the traffic for the blue team so that they can so that we can say we did it and that we can make sure they had it. I guess the other note I have is to train your blue team to prevent against real adversaries and not red teams. It's very important to keep what you're doing realistic and to ensure that after your engagements, you're doing some sort of like retroactive between your team to see where everyone can improve. Maybe it's just some process things. Maybe it's just some technical item or slip up that you got caught on, and how can we make adjustments? So we as red teams need to always improve ourselves in terms of how we're doing and ensuring that over time, the blue team is improving as well in terms of the logs they're capturing and what they're detecting. Some other notes that I skipped over, and I apologize, is I wanted to give one more resource outside of MITRE and Vector, is the C2 matrix. I apologize that I don't have the exact name for who created this, but they deserve all the credit. They organized several command and control frameworks, enterprise and open source. It gives you guidance as to exactly what those systems do, what operating systems they work on, who made them, who verified them, which is important because you don't want to be using malware as your command and control, and where you can find them. Some of these may be lesser known, but keep in mind that that may be a benefit to you. As long as the features function and allow you to reach your objective, it may be a lot less signatured than something like a popular tool would, for example, Metasploit or even Mythic or Sliver. So lesser known framework can definitely assist you there. Lastly, I'll leave you with several resources. Some of my GitHub, where you can see some of the worst written code in the world, is on the bottom right. You can also find my LinkedIn there. And then these are several resources that you can use to assist you on your red teaming. This not only gives guidance as to the type of wording, definitions, things that will help you, but also infrastructure that can assist you if you're in a time box. Sometimes you don't always have a lot of time to set up things the way that you want to. You can use things like Terraform and Ansible to get your infrastructure deployed quickly and have it operationally secure. I'll go into questions in a second, but I do have one thing for you all to kind of practice some of the things that you've learned today. In TruffleHog, there is a detector. Oh, there's several detectors. One of them is a detector for Docker. So if you can tell me the detector ID for Docker, there will be a prize. And that is all I have, everyone. I will now go to questions, if there is any. Awesome. Well, I love ending something early. I appreciate everyone's time.